So today I'm going to be going over how to run simulations on 3 different circuits in Cadence Orcad, the Cadence Orcad software. This first circuit, this is an op amp and it's an inverting amplifier. We have a gain of 5, so if you have an input of 1 volt, you have an output of negative 5 volts, and they give us a specific op amp style that we're supposed to use in our circuit. They want us to get this output that runs from negative 15. We'll run a DC sweep from negative 15 to plus 15 and get results that look similar to this. So we're going to start by opening up our software, the Cadence Orcad. If you have it downloaded properly, you can just search it. We're going to go ahead and open it in the Allegro PCP design. CISL is first one here. Click OK. And we're starting up. And once we get started here, take this start page, go ahead and close that out, and we're going to start a new project. So go to File, New Project. Now it's important here, you need to select the analog or mixed AD right here, and that's important. When naming your file, pick a file name that has no spaces in it, and preferably all lowercase, so I'm just going to call this file op amp. We'll call it op amp 1, and make sure you browse and put it where you want it here, and I'm going to go ahead and leave it right there in projects, and then click OK. And then we are asked here to create it based upon an existing project. No, we want to create a blank project. Click OK. Now we're going to come in here, we're going to rename our design, our page 1. We'll just stick with our super creative names here and name this op amp. Now, when we get into our design page, you click on your drawing environment here. We're going to come up over here to the corner and we're going to click our place parts. Now, I already have libraries in here, but I'm going to show you how to add libraries. You need the PSpice library. This is very important. You need to come in here into your Cadence. This is where it's located in mine, or my C drive, SPV16, Tools, Capture, Library, PSpice. So now we click on this, we're in the library environment, click, Control A to select all, and open all files. And now we have access to all of these files. Now it's very important when you are selecting parts that you find parts that can be simulated. They must have simulation properties, and I'll show you how to find that here in a second. So we are going to be searching for our op amp, and I'll pull it up here. This number, I'll copy it over, and Control V. We're searching for an op amp specifically with a simulation property, and that's very important. You have to have a simulation property. Although this is the TL081, it does not have a simulation property, which will be indicated down here. So I'm going to look for one with the right number of pins down here for us. And that one right here should work. So simulation property, this is what we're looking for. A little symbol right here will show up, and this says PSpice. Now we're going to use this op amp, double click on it, into our environment, and wherever you want to place it, just click it, and when you're done it'll want to place another part for you. Just go ahead and press escape, because we only need one of them. Now, just so we can get this looking exactly like our diagram for our own convenience, we have the positive on top here on our diagram, or positive on bottom, negative on top. I'm going to go ahead and take this and click it. So it's selected, right click, and we're going to say mirror vertically. And you see we had our negative switch to the top and our positive switch to the bottom. I'll zoom in there so you can see that.
Next, we need to find our resistors.
So going up in here, we're going to type in R, and you can see here we have a resistor value here that pops up the first thing, but again, we do not have any simulation property, so that's not the one we want to use. But if we look directly below that, at R analog, you do have a PSpice simulation. So we're going to double click this one, and for our diagram we need 3 resistors. So we're going to place 1, 2, 3, and then again press escape. Now align our resistors where we want them according to our diagram, and let's take a look at our diagram one more time. Okay, so according to our diagram we need R1 right here, R2 up top, and R3 we're going to click it and select rotate. R3 going down to ground. Now for our wires, the fastest, simplest way to connect them I like is the auto connect. You can draw lines, which is sometimes convenient. Auto connect to bus, auto connect 2 points. This is the one that I mainly use, and we're going to click between the 2 parts. Now, next thing we need to do is we need to search for our 3 DC voltage sources. So a lot of it is guessing on my part. I'm looking for a voltage source, so I might type in VDC, and lucky enough I have one here that popped up, a VDC source, and yes, it does have PSpice simulation, so we can use it. Double click that. Now we have 3 sources. We'll connect our first source here, source 2, source 3, and again press escape when we are done. Now our ground connections, we will not find them in here, but we will find it over here on our toolbar to the right, and you will see a little ground symbol. Double click that, and the important part about this is that you have this little 0 on your ground. If you cannot use these if they do not have the 0, the system will not recognize it as a true ground. So we're going to go ahead and use this first one that popped up, click OK, and place our grounds wherever we need them. You do not need to place everything to one ground. You can place as many grounds as you need as long as you're using the proper ground. And again, we're going to connect these up using our connecting 2 points. And we can rotate this component if we would like it to be facing up. Okay, now we have everything built here that we need, and we should be ready to run simulations, or so we think. So our value here, we're going to have 1 volt DC input, and we have 10 volts on the bottom and 10 volts on the top. Now we are going to take our voltmeter, and right here you can see our voltage level marker. If you do not have this toolbar up, this is a PSpice toolbar. It's easy to find. You're just going to go into Tools, click Tools, Customize, and then come in here and you're just going to select your PSpice and then click OK. And that will give you 2 things. That will give you this toolbar right here with New Simulation Profile, Edit Simulation, and so on, and then you'll have an additional PSpice toolbar up here with similar settings and some advanced settings for when you get a little further along. After looking over our design a little bit more, I realized that we haven't changed our R values, so I'm going to change them to what we're supposed to be seeing in our model over here of 1, 5, and 10 kilo ohms. So that's the same as switching the power sources. Double click on it, change the value, that value is good, and 5K, 10K, and click OK. Now we are truly ready to simulate, so we're going to come up here to the left corner and our PSpice toolbar, click New Simulation Profile, and we need to name our file. I'm going to name mine op-amp DC sweep, inherit form none, click Create. Okay, and I already have one existing there, so it's going to be sweep 1, and click Create. Okay, now we are almost ready to simulate. You see this window pop up down here. We can click on that. Now we are not doing these are the different type of analysis we do: time domain, DC sweep, AC sweep / noise, bias point. We want a DC sweep, so select DC sweep. Voltage source, our voltage source is V1, so let's say V1 is our voltage source. From over here we are starting from negative 15 volts and we are ending at positive 15 volts at increments of 1 volt. We'll do just fine, and that's all. Everything else looks good. Click OK. And that is creating our file for our sweep. Now we need to put in a voltage test probe here, and so come up here to the top toolbar, click on your voltage tool, and we're going to stick our probe here on the voltage output and press escape. Now we have our voltage probe and we can run our PSpice. So come up here to the run button, click run, and it will again pop up down here. So let's click it, open it, and now we see our output from negative 15 to positive 15. But in our model, we don't look exactly like what we have in the other model here that was given to us. The other model requires us to have one that goes up and then down, but ours curves back up at the last point. So what I have found to fix this issue, whether it's right or wrong, we don't want that in there, so we're going to go ahead and escape out of here. And in order to reconcile this, we are going to find a new op-amp and replace ours, which is much easier than it sounds. So I'm going to search for another op-amp, just a more generic op-amp that will do what we want it to. First time around I had to find 2 different op-amps here, so come up to our search bar in parts, type in OP-184/AD, and this is the one I found here, analog right here, and it is able to be simulated in PSpice. So we're going to put that in our model in a second. Come over to the one we have, select it, press delete, and double click our new op-amp. Do not place it directly in there because we still have to invert our part. So place it and then right click on it, and we're going to say mirror vertically, so we have our negative and positive same directions, and drop it in there. And it should be as easy as that. To check that our work is good, let's run our simulation one more time. Running simulation, click on it, and indeed we get a similar output to what was asked of us, from negative 15 to plus 15. And that's all there is to the op-amp. Our last 2 circuits are going to be half-wave rectifiers, and we are instructed to pick normal diodes, no Zener diodes, or Schottky diodes. Now our outputs for these, for the first one, we will be running a time domain simulation using 1 volt amplitude for the sinusoidal source. Try to cover 200 milliseconds using 0.2 millisecond steps. So we'll be getting a picture that looks similar to our picture here, and our second circuit should give us a more smooth DC voltage that you can see down here. Now I've already taken the liberty to go ahead and create both of these circuits. This is the second circuit. Here's our first circuit here. Now I just want to kind of go over a few points to stress on creating that one more time. It's when you go to create your new project, when you click File New, make sure you select the analog or mixed AD in your project. Now, if you want to add pages to your schematic, just right-click it and click New Page, and that's how I have 2 schematics built off this one project here. Now, make sure all the parts that you place in here, this is our last part that I placed, make sure that we have parts that have this piece by simulation or they will not work. A lot of it is just kind of guessing what your name is going to be for this voltage source here. I had to type in a few different things, finally found it on VSIN for sinusoidal voltage source. Now here you see the V off, we set that to 0. We want our voltage, obviously we don't want it off. Our amplitude is 1, frequency 60, and AC is our 1 volt input that we were told to use. Now I just picked a normal diode, and this diode will do just fine. There's lots of other diodes that will do simulations, and our resistor. Now we are going to put in our voltage probe here. We can rotate it to read our source output, and then I come into here. We need to make sure we don't have any short circuits or open circuits, which we do not, and all of our parts are placed from the PSpice folder, so we're good to go. Now we would click here, which I've already done, new simulation profile. That pops up this window. We are doing a time domain transient. That was what we were instructed to do. We were running it for 200 milliseconds, starting at time 0, with a maximum step size of 0.2 milliseconds. So click OK. Make sure when you're naming your file that you have no spaces in there, and good rule of thumb to use all lower cases, makes it easier. Now we should be able to run our simulation. If we click Run, and again it pops up down here. Now that's a problem because I have my other simulation already running. So I'm going to exit out of this. Now what I've done is I have a second one right here. I already have it built out with a capacitor in it, which I guess that works. It's just going to show you both graphs, one over the other, so that's not a problem. All I did is transferred this one, just copied the whole thing once I had it fully built, pasted it over here, found another capacitor that had simulation properties, the C1 analog here, and put that in there. So I guess we'll leave it as it is and run it. And we'll just run both of them at once. And this red line is our first circuit without the smoothing capacitor. And you can see it just comes right back up. And our other one, as the capacitor discharges, it drops down, and then till the sinusoid comes back up, picks it up, and then it drops down again. So we have created pictures that look similar to what we were asked to create. First one being here, second picture being here. And one more stress here is to make sure that you have these grounds with the 0 on it, or else your circuit won't work. Now if you follow all those little rules and don't do anything that Cadence doesn't like, hopefully it will work for you.